Okay, well, pretty straightforward. If we want to get the value of x here, we've got the value of y. So we've got the equation y is equal to 2 to the x. We know the y value. Okay, there we know it. In this case, for points, so this would be for the coordinates of m. For the coordinates of c, again, we've got the equation, but we know that x is 3. We know that x is 3 over here, which is great. Now, how do we deal with this? Well, this is easy. That's y equals 8. 2 cubed is 8. So c is the point, x is 3, y is 8. Now, what do we do here? Well, we can make that 1 over 2 to the 4 and just do a simple exponential equation, which is 2 to the negative 4 is 2 to the x. And then, of course, we can equate the exponents because the bases are the same. So the point m would be x is negative 4, y is 1 over 16. So now you're in a position to be able to work out the average gradient of f between those 2 points m and c. So let's do that. So how do we do it? So the average gradient is going to be the difference between the y. So it's 8 minus 1 over 16 divided by 3 minus negative 4. And if you tidy that up, I'm going to give you the answer direct. You can verify that in a calculator, and there is your average gradient. Now, the concept of average gradients is going to be very important in the next lesson. As we begin to move these points closer and closer to m, the average gradients are going to be changing, and they eventually, you'll see, become the gradient of that tangent at that point. So the gradient of the tangent line is going to be very similar to, or exactly the same as, the gradient of that curve at that point. But we've got to explore that in the next lesson. So just bear this in mind. Just know how to work out average gradient and you'll be fine for the next lesson. So stay with us.